Hello, it's Steve. Last time in this series we added some layers to our map parsing and finally used map data to display some tiles. This time we're going to do a little bit of refactoring and actually show some entities as well. So let's get into it. Alright, the first thing we want to do is I want to move this texture atlas layout logic out of the setup and actually put it in our map data somewhere. So let's start with that. So the sprite sheet data referenced in our map data and our object data is actually from phase 1, and it is just a sprite with some columns and tile width. A lot of that is used to initialize our texture atlas layout, so let's make a different struct here for our phase 2 that just builds a texture atlas layout for us. Okay, so this is basically the same as the sprite sheet data down here, but it has that extra texture atlas layout on it, which we can use in main. So let's go ahead and pop this in here and here to use those instead. And now that'll generate some issues down lower in the file where we're cloning that sprite sheet rather than initializing a new texture atlas data. So let's go ahead and overwrite that as well with a new texture atlas data. Oh, I gotta initialize this here. That's copying the sprite sheet from the template. We also need to make sure we have pulled in our texture atlas layouts into this system. That is what we're using over here, so I'll grab that. And we'll call it very similarly to what we're doing in here, where we're just adding a new layout. So that adds the layout, and I can actually even grab this layout as well and put that in here. Get these properties from the right spot. Did I put 3 E's in sprite sheet? Oh my god. So that initializes it here. We also need to do basically the same thing down here for the map sprite sheet. I mean, in our use case, this is going to be the same as the other one, but there's no real reason to not load it separately. So let's just do it. And then we'll just basically do the same thing as up here for the sprite sheet. Except we're going to grab the map sprite sheet instead. That needs to be duplicated. Still, that's okay. There we go. Okay, so now we have template data directly on our map server. So what we can do with this, pop over to main RS, we can get rid of texture atlas layouts. We can get rid of these 2 variables. And then down below, instead of grabbing the texture atlas layout that we just made, we can grab the maps texture atlas layout, and then we'll just clone that into there. So there, that's a lot cleaner for that. I like that. Let's make sure that's still working by running it. All right, still rendering. Looks good. Next thing I want to do is actually make some of these constants. It's really silly. I mean, I know these exist on the map and we went to all the trouble of pulling them from the map file, but having to recalculate this twice is kind of bothering me, and there's just a lot of things that would be a whole lot simpler if they were just in constants. So let's make a little constants section up here, and let's define some variables, and let's define some constants. So here we have the Z of the floor. In Bevy, I think anything in the negatives is actually not visible, so as far as 2D cameras go. Entity Z, I think we actually want to put that to 1, and probably we'll want to switch this to Entity Z offset at some point, but for now we don't really care. They can all be at the same layer. Scale does not need an underscore, but scale is just a pixel scale. Since this is pixel graphics, we don't want it to be tiny, so we're bumping that up a bit to 4. The tile width is the width of our tiles. That's always going to be the same. I don't plan on doing anything with 32 wide tiles. anytime soon. Half tile width, we'll talk about that in a second for math. Map width is always going to be the same. It's going to be 30 tiles wide, and then our tile width. And then half map width, the same thing. We're going to talk about that with some math in a little bit. So let's roll on down and replace a few things. We can do floor Z here. And instead of calculating these, we can now do a little helper function. And then we can do basically just this. And we're going to take this in as a F32, so we don't need to do this. And then we can also have tile width here, and then half map width, and half tile width. And this is returning an F32. Alright, so this is a version of this. We could put this here, but instead, why don't we just go ahead and do coordinate to position here with X as F32. And then the same thing with Y. Of course, Y is going to be upside down. So there we go. And now we can get rid of that. Oh, I don't need to be calculating these anymore. Or saving the scale here. There we go. This function's a lot smaller now. Scale. Oh, I need to multiply these by scale too. Oopsie. And while we're at it, let's just make another one, just in case we ever need to go from position to coordinate, which I don't think we ever will. But we might as well have a way to reverse this logic. Just checking my math here real quick. This goes on the other side. Okay. Alright, just testing that real quick to make sure it's still going. And that's still running just fine. So there's that portion of the refactor done. Let's render some entities. Here we're going to loop through all of the pieces of object data in our current map and commands.spawn them. Now, what needs to be on here? We're going to need a sprite bundle and a texture atlas for now, just the same as the tiles. In fact, let's copy what the tiles are using and go from there. So instead of X and Y, we want object.x, object.y, and those are also going to be like they're on the same grid, so it makes sense to flip that as well. And Z is going to be entity Z rather than floor Z. Same scale, same texture, and as a texture atlas, let's use the objects sprite sheet texture atlas layout, and then instead of the data, we can just use the objects sprite index. Okay, let's see what that looks like. Those are in a strange location. Oh, I see. I see what happened here. Let me explain myself here. At an earlier stage, this tile map was for some reason shifted over here. I noticed that that had changed, but in my code, I had updated the tiles, but not actually the objects. So let's fix that. Save, and then if I look at the map again, look at that. They're all aligned again. So that's nice. So let's close that and run again, and that should be a lot closer. Okay. Now they're just off by 1 on the down direction. That's easy enough to fix. Let's just subtract 1 from the Y. 1.0. See what we get. Is it subtract 1 or add 1? Wait, what? Oh, right. Duh. Not subtract 1 from this Y, subtract 1 from that Y. Because I'm subtracting it from the coordinate, not subtracting it from the position. There we go. Things are in the right spot, and they're looking beautiful. I like that. Now let's do something we've never done before in this series, and actually explain what we're going to do next in a little bit more detail, as far as the why and maybe the development philosophy behind it. So now that we have this set up in such a way that we can start adding logic to our entities and things, this map loader file is honestly bothering me. I'm going to put up a little chicken scratch diagram from my notebook here. Right now, This is more or less how I see the game logic working. Actually, in actuality, the amount of game logic we have is next to zero. But you can think of game logic there as where we're actually going to be coding our game. We have our main Rust here, which is basically going to be connecting our game logic to how Bevy works. That's going to be doing all of our Bevy setup, as well as hooking into our logic down the road for things like adding logic to these entities. And then there's the map loader, which is connecting our game logic to tiled. So right now, that is actually a whole lot cleaner than it was before in main, where instead of loading in a whole bunch of different resources and resource loaders and everything else, we just have one map server that we're asking for things. This is the sort of interface we need, but this file isn't really separated in the way that we need. So what we're going to do, here's the same diagram, but what we're going to do, which is down the line when we're adding new features, we're going to actually be adding them more or less as plugins to what we have here, and that's going to split up our main logic so that we don't have too much in this one file. But right now, or rather in the next episode, we're going to go through our map loader and break that into two pieces. You can see these two pieces as basically phase 1 and phase 2 here, where one of them is going to be concerned with parsing the tile files and getting those all into memory, and the other one is going to be concerned with loading and organizing that data in a way that's easy to consume down the road. So one of them is an adapter from tiled to some intermediary file data, and the other is an adapter from that raw file data into something our game cares about, some game logic type code. So that's what we'll be doing next time. We actually got one of these done in one part finally. Thanks for watching. Peace.